This is part B, question 9 of the Seoul National University's Mathematics Aptitude exam that was held in 2024, 4th of February. The reason I chose this question is because this looks like a very good practice for IB Math AAHL students that wants to, I guess, feel outside the box and not only try questions that require comfortable mathematics. Because this question is special. This question asks to basically differentiate the function x to the x, where the domain is from 0 to infinity. And this, at least I have never seen in any practice papers or past papers ever. So this might be a good attempt, a good new shot of calculus practice. So please have a go. So I think the key point here is the 0 to infinity. If it was negative, it would have not worked, and you'll see why. What we want to do is differentiate the function x to the x to the x. And we cannot use our normal laws of indices or exponents because they are separately powered. So our goal is to simplify these indices, these powers, so that we can differentiate it. And I will say that this is hard to see if you've never seen this step in the method before. If we have fx equals x to the x to the x, I will just use the logarithms in both sides. The base does not matter. ln of f of x equals ln of x to the x to the x. Mathematically, this has nothing wrong because it's the same side. And with the laws of logarithms, we can state that the indices can be multiplied by the logarithm's base itself. So ln of f of x equals to x to the x multiplied by ln of x, right? And notice, the whole reason why this step works is because the domain x is defined as all positive real numbers. So, therefore, and excluding 0, therefore those numbers can go in as as numbers inside logarithms. So now the next step is to differentiate both sides. If you differentiate a logarithm, the function inside the derivative becomes f prime x over f of x because of the composite function chain rule, right? And the next step is this. We know how to differentiate because that is a product rule. That's a product of two different functions. They're not indices. So the whole point of logarithms is just to simplify our complicated function in order to a form that we can calculate with. So that will be x to the x times ln x differentiated 1 over x plus ln x times x to the x differentiated, right? But we don't know what x to the x differentiated is. So let's do that. Let's say g of x equals x to the x. Then we'll do the same thing because these are indices. It will be easier to look at them as products by using logarithms again. ln of g of x equals ln of x to the x. Therefore, ln of g of x equals x times ln x. Therefore, the left-hand side differentiated is g prime x over gx, which equals to x normal ln x differentiated plus x differentiated times ln x normal, right? Therefore, this is just ln x plus 1. That is g prime x over gx. Therefore, g prime x equals gx all multiplied by ln x plus 1. And gx, obviously we defined it as on top, x to the x. Therefore, is x to the x times ln x plus 1. Right? Yes, that is correct. Therefore, we can substitute that back into our function. So f prime x over fx is x to the x divided by x plus ln x times this differentiated, which is x to the x times ln x plus 1. Right? And obviously, that is what f prime x over f of x, right? So our final equation would be f prime x, and I'll actually before that simplify this as x to the x of 1 over x plus ln x squared plus ln x. Okay? I just simplified that. And so f prime x, which is the differentiated version of x to the x to the x, is x to the x to the x times x to the x multiplied by ln x squared plus ln x plus 1 over x. We can maybe simplify this one last time to x to the x plus 1, right? Is it x to the x plus 1 times x? So that's x to the x plus x, right? Yeah. Multiplied by ln x squared plus ln of x plus 1 over x. And that is the derivative of x to the x to the x. Thank you very much.